polynomial rings over the field f. So first of all, definition என்னன்னு பார்த்தீங்கன்னா f enter the field, how to define the f of x. The ring of polynomials in the determinant indeterminate x denoted as the f of x is the set of all the expression of the form the polynomial. Formal expression of the form a0 e plus a1x plus a2x square plus and so on a n x power n greater than or equal to 0 is a non-negative integer and the coefficients are belongs to f. This is the collection of all polynomials is called that f of x. And equality of the polynomial idella well known irupinga nenikren, that is the two polynomials எப்ப ஈக்குவலா இருக்கும்னா the corresponding coefficients should be equal ஆ இருந்தா ரெண்டு polynomial ஈக்குவலா இருக்கும். addition எப்படி பண்ணுவோம்னா corresponding coefficients ஆட் பண்ணி once again correct இன்னொரு polynomial create பண்ணுவோம். for example ரெண்டுமே வந்து ஒன்னு m degree polynomial இன்னொன்னு n degree polynomial ஆ இருந்ததுன்னா corresponding coefficients add பண்ணுவோம். that's all. a0 plus b0 constant term, a1 plus b1, a2 plus b2 like that add பண்ணி proceed பண்ணுவோம். that is இங்க depend பண்ணிருக்காங்க ci equal to a plus bi with a equal to 0 I greater than m ஆ இருந்ததுன்னா bi equal to 0 for I greater than n ஆ இருந்தா like that. so the same way product define பண்ணலாம். how to product the two polynomials அப்படினு பாத்தீங்கன்னா one m degree polynomial இன்னொரு n degree polynomial. the product of two polynomials is also polynomial, that is in the product of corresponding coefficients, that is ci equal to a0 bi plus a1 bi minus 1 plus and so on ai b0, that is in the short form summation j equal to 0 to I, that is aj bi minus j. This is equivalent to multiplying the polynomials in the usual way by distributing the terms the x power a x power b equal to x power a plus b like that. okay, for example பார்த்தீங்கன்னா இங்க 3 degree polynomial, 2 degree polynomial இன்னொன்று வந்து degree 3 உள்ள ஒரு polynomial, ரெண்டுத்தையும் மல்டிப்ளை பண்ணும்போது அதோட corresponding coefficients தெரியும். so we can multiply normal multiplication, so we get the sum output, that is in the polynomial இது ஒரு 3 term இது ஒரு 3 term மொத்தம் 6 terms வரும். அதை group பண்ணீங்கன்னா so here we get it the 5 terms, that is a polynomial. and a ring structure of f of x, so ring structure of f of x na ரெண்டு operation இருக்கும். that is the this f of x form a commutative ring with unity. obviously p of x q of x p of x equal in the polynomial sense la. and unity constant polynomial 1 is the multiplicative identity, am I correct? that is 1 plus 0x plus 0ax square plus 0ax cube and so on plus 0x power m is the constant polynomial 1 is this is called the multiplicative identity. so with respect to multiplication identity element exists, with respect to multiplication commutative property is true, and also this satisfy that with respect to addition is abelian group, and multiplication is associative and also satisfy the distributive property, so that this capital f of x the collection of all polynomials form a commutative ring with unity. what about the nature of the field? வேணும்னா that is the exist ஆகணும், inverse non-zero value க்கு inverse exist ஆகணும். then every non-zero polynomial has the inverse exist ஆச்சுனா then it is called the field. obviously this is the field. இங்க வந்து இப்போ next degree of the polynomial means இங்க இந்த that is deg degree of f of x. it is here this the degree of the polynomial, the highest power is called the n. so the degree is the highest power of x and non-zero with a non-zero coefficient and zero polynomial as undefined degree. polynomial க்கு வந்து degree வந்து கிடையாது, undefined degree. Polynomial degree 0 is called the constant polynomial. Polynomial degree 0 என்றது constant polynomial. இதெல்லாம் கூட நம்ம கோட்டை விடுவோம். So this is a very important concept. And the coefficients an of the highest power is called the leading coefficient சொல்லுவாங்க. That is called the leading coefficients. So and Euclidean ring structure, so that is a Euclidean ring structure where a degree function will serve as the Euclidean function. Degree function serve as the Euclidean function d of x, that is making capital f of x is a Euclidean ring. So d of f of x means degree of f of x for the non-zero polynomial. Because of zero polynomial, the degree is undefined. So degree of f of x is non-negative integers for f of x is not equal to 0. Degree of f of x is always less than or equal to degree of f of x to g of x for g of x is not equal to 0. So division algorithm is true for every two polynomial in f of x for with non-zero polynomial, that is g of x. There exist the two polynomial q of x and r of x. Q of x and r of x. Q of x and r of x and f of x equal to q of x into g of x. ஸோ நார்மலாக நம்ம அங்கே யூக்ளிட் ரிங் படித்தது தான், இங்கே வந்து நம்ம பாலினாமியலில் படிக்கிறோம், அவ்வளோதான் வித்தியாசம். ஸோ எஃப் ஆஃப் எக்ஸ் ஈக்குவல் டு த ப்ராடக்ட் ஆஃப் q of x into g of x plus r of x with r of x equal to 0 or degree of r of x less than degree of g of x. Degree of r of x less than degree of g of x. Okay, well, this is called the formal Euclid ring, and polynomial rings acts the Euclidean domain. So the degree of the product, that is the degree of the product when you take the two non-zero polynomial, and degree of f of x into g of x is nothing but degree of f of x plus degree of g of x. Okay, and f of x, g of x are non-zero elements in something, and degree of f of x is always less than or equal to degree of f of x into g of x. And capital F of x is an integral domain. So the field of rational numbers, that is since f of x is an integral domain, we can construct the field of fractions, that is called the field of rational functions x over f in x over f. This consists of all expression of the form that is f of x by g of x, where f of x, g of x belongs to f of x and g of x is not equal to 0. G of x is not equal to 0. Okay, well, that is the collection of the rational function, and division algorithm for rational functions of the polynomial, that is the f of x, g of x is not equal to 0 in f of x. There exists a polynomial t of x and r of x in f of x such that f of x equal to t of x into g of x plus r of x. The remainder should be equal to 0 or degree of r of x less than degree of g of x. This is called the division algorithm for the polynomials. And f of x is a Euclidean ring. So f of x with a degree function is a Euclidean ring, that is satisfy the condition of the Euclidean concept. So since f of x is a Euclidean ring, it is also principal ideal domain and unique factorization domain and Noetherian. Okay, well, this is the Euclidean ring. And properties of polynomial rings over the field. F of x is a principal ideal ring. So since f of x is a Euclidean ring, it is automatically the principal ideal ring. So every ideal in f of x is generated by the single element. Every ideal in f of x generated by the single element. And Bezout identity for the polynomial, that is means the f of x, g of x belongs to capital F of x. They have the greatest common divisor. The greatest common divisor of the f of x and the g of x is d of x. Okay, d of x, that can be expressed in the form of அங்கே lambda நம்பரில் போடும்போது lambda something plus mu something போட்டு போகுது lambda f of x plus lambda இங்கே a b னால lambda a plus mu b னு that is here the polynomial when you define for the polynomial. So lambda f of x plus mu of x q of x mu of x q of x, the lambda x comma mu of x belongs to f of x. Okay, so this is called the Bezout identity for the polynomial. Here d of x is the greatest common divisor. The next very important concept, that is the irreducible. So that is irreducible means, okay, well, mostly very important, a polynomial p of x is said to be irreducible over f. So when you said the polynomial is irreducible, that is p of x can be expressed the product of linear factors. So that is a of x, b of x, that is 1 of a of x or b of x or degree 0. Okay, so that is a constant polynomial. Then that is called the irreducible polynomial. That is called the irreducible polynomial. வந்து ஃபேக்டரைஸ் பண்ண முடியல அப்படின்னா that is called the irreducible polynomial. ஃபேக்டரைஸ் பண்ண முடிஞ்சதுன்னா that is called the reducible polynomial. So irreducibility depends on the field டிபெண்ட் பண்ணியிருக்கும். ஸோ இதை பேஸ் பண்ணி ப்ராப்ளமும் கேட்பாங்க. So the x square plus 1 அப்படின்னு பார்த்தீங்கன்னா that is called the irreducible over r. irreducible over r. ஏன்னா ஆர்ன்றது ரியல் ஃபீல்டு. ஏன்னா ரியல் ஃபீல்டை பொறுத்து இதை ஃபேக்டரைஸ் பண்ண முடியாது. ஆனால் இதை வந்து ரெடியூசபிள் ஓவர் சி பிகாஸ் ஆஃப் த எக்ஸ் ஸ்கொயர் ப்ளஸ் ஒன்று எக்ஸ் ப்ளஸ் ஐ இன்ட்டு எக்ஸ் மைனஸ் ஐன்னு எழுதலாம். ஐன்றது காம்ப்ளெக்ஸ் நம்பர்ஸ். ஸோ திஸ் இஸ் ரெடியூசபிள் ஓவர் சி பட் irreducible ஓவர் ஆர். இட்ஸ் அ வெரி இம்பார்ட்டண்ட் concept and very important example for understanding the irreducible over the field. Okay, and unique factorization, any polynomial in f of x can be written in a unique manner, any polynomial as a product of irreducible polynomial, as a product of irreducible polynomial. That is called the unique factorization theorem சொல்லுவாங்க, லெமான் சொல்லுவாங்க. எந்த ஒரு பாலினாமியலும் நாம that is product of irreducible polynomial எழுதலாம் in f of x ல. It's a very simple statement. Okay, and maximal ideal and irreducible polynomial. The maximal ideal means already நம்ம டிஸ்கஸ் பண்ணது, the ideal generated by some elements of the f of x, and that means a equal to p of x in capital F of x. That is a maximal ideal அப்படின்னு நான் சொல்லணும்னா இந்த p of x ன்றது என்னவா இருக்கும்னா irreducible over f ஆ இருக்கணும். ஸோ இதான் பெருசாக இருக்கும். that is p of x is irreducible over f ஆ இருந்ததுன்னா this is called the maximal ideal. So very simple definition. Okay, and field extension, that is example q of x divided by x cube minus 2. So q means that is the rational number. P of x equal to x cube minus 2. Okay, this is since x cube minus 2 is irreducible over q means rational number. This is irreducible over q that is the factorize பண்ணீங்கன்னா rational numberல வராது. So then ideal A x cube minus 2 generated by x cube minus 2 is maximal. Am I correct? X cube minus 2 is maximal because of this is irreducible over q. So the q of x divided by x cube minus 2 is a field. Try to understand this concept. Okay, q ன்றது field இங்க மாத்துனீங்கன்னா okay, that is this is cannot be field இங்க மாத்தும் பொழுது q க்கு பதிலா r எடுக்கிறீங்க அப்படின்னா இதை ஃபேக்டரைஸ் பண்ண முடியும். இது irreducible இருக்காது. இது எப்படி ஃபேக்டரைஸ் பண்ண முடியும்? x cube the 2ன்றது this is cube எழுதுனீங்கன்னா a cube minus b cube ஃபார்முலா அப்ளை பண்ணலாம். So how to express in terms of cube? That is minus this is 2 power 1 by 3 whole cube. So this is equal to x minus cube root of 2 into x square and plus x into cube root of 2 plus cube root of 2 whole square. That means 2 power 2 by 3. Okay, correct. Cube root of 2 whole square. So இது factorizable. These are belongs to R. These are belongs to R. So over R நாம் எடுக்கும்போது this is a reducible. இது reducible னா we can't express the maximal ideal, so that's this cannot be a maximal ideal generated by the some ideal, that is x cube minus 2 cannot be maximal. So the q of r of x divided by x cube minus 2 cannot be a field, cannot be a field. So அதனால அந்த field depend பண்ணி அதை நாம எக்ஸ்பிரஸ் பண்ணணும். என்ன வேணாலும் கொஸ்டின் கேட்கலாம், இதை அண்டர்ஸ்டாண்ட் பண்ணிட்டீங்கன்னா இட்ஸ் அ வெரி ஈஸி, வெரி ஈஸி கம்பேர்ட் டு தட் other one. So the q of x divided by x minus 2 x cube minus 2 elements represented. How to represent the elements of the q of x divided by x cube? Already this is a field in solution, is a coset of the form the rational function, that is a quotient function, is of the form that is f of x plus a. By the division algorithm, this f of x q of x into x cube minus 2 plus r of x, degree of r of x should be less than 3. So r of x equal to a0 a1x a2x square நீங்க எடுக்கும் பொழுது f of x plus a, this is expressed, this is f of x, am I correct? So plus a, and t equal to x plus a, t equal to x plus a, then every element is of the form a0 a1 t plus a2 t square, these are belongs to q, a0 a1, then the structure t cube minus 2, this is the x plus a whole square minus x plus a whole cube minus 2, and this is when you express the x cube minus 2a x square like that, then this is become the minus 2 plus a x cube minus 2 plus a, that is because of in the structure that on the cube that is defined x cube minus 2 plus a, this is equivalent to a, this is equivalent to a, this is equal to 0, am I correct? So from this t cube equal to 2, so the representation is unique, this is equal to something, so that this implies the polynomial a0 minus b0 a1 minus b1x a2 minus b2x square should be belongs to the a, that is generated by the x cube minus 2, am I correct? So therefore this polynomial has degree less than or equal to 2, so while every non-zero element of a has degree greater than or equal to 3, so therefore there must be the zero polynomial. That zero polynomial means ai equal to ba, that is a0 equal to b0 a1 equal to b1 a2 equal to b2 for every I. So the non-vanishing of the determinant, that is the next idea of the system of solutions, system as a solution if and only if the determinant of the coefficient matrix is non-zero. So that is determinant is delta equal to a0 cube plus 2a1 cube plus 4a2 square like that. That is we want to show that the a0 a1 a2 should not equal to 0 comma 0 comma 0 in q. So then delta is not equal to 0. So how to find out the greatest common divisor, that is x cube minus 6x square plus x plus 4 x cube minus 6x plus 1 over q. So the normal procedure தான், that is factorize பண்ணிட்டு evaluate பண்ணுறது. So x power 5 minus 6x plus 1 divided by this one. When you divide by this one, we get it a normal division down. So x cube minus 6x plus 5. So x cube minus 6x square plus x plus 4 into quotient. This is the quotient after divided by this one. Long division you divide pannalam. And x cube minus 6x square plus x plus 4. X power 5 minus 6x plus 1. So x cube x square all multiply, that is called x power 5 minus 6x cube and plus x cube, so plus x power 4, that is x cube into x square x power 4 6x power 4 6x power 4 and x into x square x cube and plus 4x square. So இதில் x cube cancel ஆயிடும், சைனை மாற்றினீங்கன்னா இது ப்ளஸ் ஆகிடும், இது மைனஸ் ஆகிடும், minus side like this calculate பண்ணீங்கன்னா we get the quotient this one and the remainder this one. Once again divided by the x cube minus 6x square, this is by 140x square minus 35x minus 139, we get this one. Okay, so and then divided by, once again the 140x square should divided by this one. Then இது வந்து காமன் மல்டிபிள் இருக்குது, அதை வெளியே எடுத்துடலாம். காமன் மல்டிபிள் வெளியே எடுத்துட்டிங்கன்னா x plus 1 டிவைட் பண்ணிங்கன்னா போதும். That is 140x square. So this is into plus 0 வருது. So 0 வர வரலையும் நாம் ப்ரொசீட் பண்ணோம். Since the last non-zero remainder is, this is the last non-zero remainder, that is multiplied with some element constant. So we can multiply by a unity, that is GCD is x plus 1. This is, we can leave it, that's GCD is x plus 1 is GCD for this polynomial. I thought a little bit difficult, that's all, but it's a very simple procedure already discussed in the, I thought, 10th standard book like okay. So x square GCD of x square plus 1, x square 6 x cube plus x plus 1 over q. The same way when you proceed like that, over q, the field is very important. அதுதான் நம்ம 10th படிக்கிறதுக்கும் இங்கே படிக்கிறதுக்கும் உள்ள வித்தியாசம். இங்கே ஃபீல்டு டிபெண்ட் பண்ணி நாம் ஃபேக்டரைஸ் பண்ணணும். ஓகேவா, அங்கே அது மாதிரிலாம் யோசிச்சிருக்க மாட்டோம், லாங் டிவிஷனில் போட்டு ப்ரொசீட் பண்ணியிருக்கோம். ஸோ இங்கே டிவைட் பண்ணும்போது ரிமைண்டர் ஃபஸ்ட் டேர்ம்லேயே 0 வந்துருக்கு. ஸோ தட் எக்ஸ் பவர் 6 ப்ளஸ் எக்ஸ் கியூப் ப்ளஸ் எக்ஸ் ப்ளஸ் 1 அண்ட் எக்ஸ் ஸ்கொயர் ப்ளஸ் 1 டிவைட் பண்ணும்போது, ஸோ இதால் தான் டிவைட் பண்ணுறோம். டிவைட் பண்ணும்போது உங்களுக்கு கிடைக்கிற கோஷன்ட் இது. ஸோ த ரிமைண்டர் இஸ் கால்டு ஜிசிடி. ஓகே, ரிமைண்டர் 0 வரதுனால, சாரி ரிமைண்டர் என்ற கோஷன்ட், கரஸ்பாண்டிங் கோஷன்ட், ஸோ இஸ் கால்டு, சாரி கரஸ்பாண்டிங் கோஷன்ட்டில் டிவைசர், தட் இஸ் த ஜிசிடி ஈக்குவல் டு எக்ஸ் ஸ்கொயர் ப்ளஸ் 1. So the same way irreducibility test, once again over Z2, here the Z2 is the field. நம்ம நேற்றே பார்த்தோம் எதெல்லாம் ஃபீல்டு எதெல்லாம் ஃபீல்டு இல்லைன்னு. ஸோ எக்ஸ் ஸ்கொயர் ப்ளஸ் எக்ஸ் ப்ளஸ் 1 ஓவர் Z2. ஸோ இது வந்து அவுட் டு irreducibility டெஸ்ட், தட் இஸ் பாலினாமியல் ஆஃப் டிகிரி 1 ஓவர் Z2, தட் இஸ் எக்ஸ் ப்ளஸ் 1. ஸோ தென் எஃப் ஆஃப் 0 கண்டுபிடிச்சிங்கன்னா, இயர் எஃப் ஆஃப் 0ன்றது 0 ஸ்கொயர் ப்ளஸ் 0 ப்ளஸ் 1 equal to 1, this cannot be 0. F of 1 find out பண்ணீங்கன்னா, that is 1 square plus 1 plus 1, that is 3 வரும். 3 modulo 2ன்றது 1 தான், 1 modulo 2ன்றதும் 1 தான், 1 plus 1ன்றது தான் 0, that is 2 modulo 2 தான். So no roots in Z2, ஏன்னா Z2ல ரெண்டே எலமெண்ட் தான், that is 0 and 1, 0 and 1 மட்டும் தான் இருக்கும். So no roots in Z2. So since degree 2 it is reducible, degree 2 is irreducible, this polynomial is irreducible over Z2. The same way for over Z7, x square plus 1 over Z7. So I will check that that is a 0 square plus 1 for the 0, that is modulo 7 is 1, 1 square plus 1 2, and 2 square plus 1, that is 4 plus 1 5. So 3 square plus 1 10 modulo 7, that is 3, and 4 square 16 plus 1, that is 17 modulo 3, and 5 square plus 1 25 plus 1, that is 26 modulo 7, that is 5, and 6 square 36 plus 1, that is 37 modulo 7, that is 2. ஓகே, எதுக்குமே 0 வரல. ஸோ இதுவும் என்னது, irreducible over Z7 ஆகும். திஸ் இஸ் த irreducible over Z7. த சேம் வே x cube minus 9 over Z31, ஓவர் Z31. இது எப்படி செக் பண்ணலான்னா, தட் இஸ் x cube congruent to 9 modulo 31, that is the cubes modulo 31, that is 1 cube 2 cube like that, 3 cube and 4 cube. எதுக்கு 9 வருதுன்னு பார்க்கணும், that is the 5 cube and 6 cube. 6 cubeன்றது that is நம்ம ஏற்கனவே சொல்லாமல் ஷார்ட்கட் மெத்தட் கூட அப்ளை பண்ணலாம். So 6 cube and this is a very simple value, that is a 5 cube 125 modulo 31 போடலாம். 6 cube வரும்போது 216 என்றது we can express 31 into 7 minus 1, that is the minus 1 modulo 30, and 7 cube என்றது 343 என்றது is congruent to modulo 31 is 2. 8 cube like that, 9 cube, 10 cube and 11 cube, 12 cube and 13 cube, everything that is the 15 cube is also modulo 31 is so none of them equal to modulo 31 is 31. Okay, because of this is over the is 31. So since the degree is 3, no roots, degree 3 is no roots, it is irreducible over is 31. The same way this is a z11 modulo 11. So modulo 11 means this is the modulo inge vanda 9 varudhu paranga, that is a 4 cube. The modulo 11 is 9 apna 4 cube equal to 64, that is the modulo 11 is 9, that is x equal to 4. So x cube minus 9 we can express x minus 4 into x square plus 4x plus 5 x square plus 4x and x square plus 4x plus 9. So modulo 9, so that is x equal to 4 into the split taken up from this, that means x square minus 4, this is we get it the divided by x minus 4, we get this one, x cube minus 9, that is x into x square and minus 4x. When you sign change it, this is become the plus 4x and minus 9, once again plus 4 into x, not the x square, x cube, sorry, x cube minus 9, x minus 4, this is equal to x square, that is x cube and minus 4x square. So when you after sign change, this is become the plus 4x square. So plus 4x square minus 9, that is plus 4x plus 4x. So that is 4x into x, 4x square, that is minus 16x. So am I correct? Minus 16x. Once again sign change பண்ணும்போது, that is the plus side, 4x square cancel, that is the 16x minus 9. So once again this is the plus 16, here plus 16, here modulo 11 போடணும், modulo 11 ன்றதனால it's become the 5, it's become 5. So here 16x, இங்கேயும் நீங்கள் modulo மாற்றிக்கலாம், that is the minus 16 4 so 64 and minus 64. So sign change பண்ணதுனா this is become the 0. 64 na, that is 55 I thought, minus plus, that is 64 and 59, sorry, that is the 9, that is the minus plus 55. So that is the modulo 11, that is inge the modulo 11 போடும்போது this is 16 become the 5. So this is the x cube minus 1, that is the modulo 11 la, it is reducible. So like this irreducible reducible identify பண்ணலாம். And relatively primeness in the field extension, suppose f is the subset of k, be a fields and f of x, g of x belongs to f of x. These are relatively prime in f of x. Bezout identity, there exists the lambda x and the mu of x in f of x. This obviously is the contained in f of k of x, such that lambda x f of x plus mu x g of x equal to 1. So same equation is true in k of x. The common divisor of f of x and g of x in k of x must divide by 1, that there must be a unit. So therefore f of x and g of x are relatively prime in k of x. Okay, so this is the relative primeness in the field extension. So that means f of x for and f is the subset of k is the field, and f of x g of x relatively prime in f of x, and there exists the Bezout identity, that is lambda f plus mu g equal to 1. So this equation is true in k of x. Okay, and any common divisor f of x and g of x and k of x must be divided by 1. So that must be unit. Therefore f of x, g of x are relative prime in k of x is also. So that is the extension, field extension, relative primeness extension to k of x. So field with 121 element, field with 121 elements. So that means f of x divided by x square plus 1. Here f equal to z11. So the irreducibility pathina x square plus 1 is irreducible. That x square plus 1 is equal to 0, that is x square equal to minus 1. Congruent to minus 1 is the modulo 11. Minus 1 modulo 11 is equivalent to 10 modulo 11. That is 10 plus 1 11, 11 modulo 11. That is this is congruent to positive la nama express பண்ணும்போது 10 modulo 11. Z11 that is 0 1 2 3 1 0 1 4, that is in Z11 ல வந்து இதெல்லாம் வந்து 10 3 0 1 4 9 this is okay. This is a 0 1 2 3 4 something. Now 10 is not a square, that is so no roots is irreducible. That is I will try to find out that 0 square plus 1 0 அப்புறம் 1 square plus 1 2 square plus 2 like that modulo 10 வர மாதிரி. So no root no roots, that is modulo 10 that is 10 modulo 11, therefore it is irreducible. So degree of x square plus 1 equal to 2 here. So the elements are of the form a plus bt, and a comma b belongs to z11. So that therefore t square equal to minus 1, that is 11 into 11, t square equal to minus 1, therefore 11 into 11, that is equal to 121 elements, that is 121. There are the same way f of x divided by x square plus x plus 4. So the இங்கே வந்து பார்த்தீங்கன்னா f equal to z11. When you try to find out the determinant, that is 1 square minus 4 into 1 into 4, that is b square minus 4ac. Okay, but that is okay, 4ac, that is equal to minus 15. Minus 15 modulo 11 is equivalent to that is minus 15 modulo 11 is equivalent to 7 modulo 11. So that if 7 is a square, modulo 11 la pathina the squares are 0 1 4 and 9 5 like this. For the modulo 11 is not a square, so therefore it is irreducible. So therefore elements are of the form a plus bt, because of its degree is 2 ன்றதுனால a comma b ன்றது z11 ல இருக்கும். That is t square plus t plus 4 equal to 0. Again this is the 11 elements is of the form 11 into 11, that is equal to 121 elements because of degree 2. And isomorphism between the two fields, that is both fields are finite fields of order 11 square, that is equal to 121. The classification of the finite field exactly one field up to isomorphism of the each prime power order, that is therefore these two fields are isomorphic, that is alpha be the root of x square plus 1 equal to 0 in the first field, beta be the root of x square plus x plus 4 equal to 0 in the second field. We want to find the linear map from alpha to c beta plus d. So that is the preserve the field structure. So that is records c beta plus d whole square plus 1 is equal to 0. So when I expand the a plus b whole square formula, so that beta square is equal to minus beta minus 4 beta, because of beta is the root of this one. So beta square equal to minus beta minus 4. So when you substitute here c square minus beta minus 4 2cd beta plus d square something, So when you combine simplify பண்ணீங்கன்னா like this இது மாதிரி கிடைக்கும். So each and every term should be equal to 0, so that c into minus c plus 2d இதை factorize பண்ணீங்கன்னா, and c is not equal to 0, map not bijective, so therefore d should be equal to c by 2, d equal to c by 2. So when you substitute AR in the first equation, that is minus 4c square, c square by 4, that is d equal to c by 2 ன்னு போட்டிங்கன்னா, so இதில் இருந்து c square equal to 4 by 15 வருது. So 4 into 15 power minus 1, that is modulo 11. So 15 congruent to 4 modulo 11, that is 4 inverse congruent to 3 modulo 11, that is c square equal to 4 into 3, that is 12. 12 congruent to 1 modulo 11, therefore c equal to plus or minus 1 ன்னு வரும் modulo 11, therefore c equal to 1, and d equal to 1 by 2, that is equal to 6 modulo 11 வந்துரும். It's a very simple calculation. So 2 power minus 1 is congruent to 6. Therefore from this, what is the conclusion அப்படின்னு பார்த்தீங்கன்னா, that is that isomorphic is exists. The isomorphism alpha to beta plus 6, the c and இது ஒன்றாக find out பண்ணுறோம். That is isomorphism is alpha tends to beta plus 6. That is define the mapping. Mapping you look like this is the mapping. Isomorphism is exist. The same way r of x by x square plus 1, that is isomorphic to c. R of x by x square plus 1, that is isomorphic to c, that is because of it is irreducible. And field equal to r here, the x square plus 1 is irreducible over r because of no real roots for this one. So this is obviously field. Elements of the form a plus bt, because of it's a quadratic, and t square equal to minus 1 and when you substitute here. And define the mapping, this is to c is of the form pi of a plus bt equal to a plus bi. Am I correct? So well define equivalent define பண்ணலாம், எப்போ இது ரெண்டு ஈக்குவலாக இருக்குன்னு addition define பண்ணலாம், and then addition and multiplication, that is homomorphism concept, and this is a bijective obviously, so this is isomorphic to c. The same way r of x by x square plus 1 is isomorphic to c. So for the field of real of real numbers, so is a field of isomorphic to the complex number c. That is a very important idea. Okay, so this is a field. We discussed the same concept. So every element in r of x by x square plus 1 is of the form a plus bx plus in r of x la irukkiradhu, that is plus x square plus 1. So t equal to x plus x square plus 1, that is t square plus 1 என்றது equal to 0, t square equal to minus 1. ஏற்கனவே போட்டு தான், leave it, this is the idea. So rx by r of x divided by x square plus 1 is isomorphic to the complex numbers. So that is the derivative of the so f be the field of rational numbers, and f of x equal to a naught a1x plus a n x power n, define the derivative f dash of x equal to something, and f of x is divisible by the square of the polynomial if or only if f of x and f dash of x have the GCD positive degree. It's some important idea. So what is the derivative criterion for multiple root? So what is the derivative criterion? Field f be the field of rational numbers. Field of rational numbers, the f of x defined the like this nth degree polynomial, f dash of x is like that. So that is actually what is the idea means, f of x is divisible by the square of the polynomial if or only if f of x and f dash of x f of x and f dash of x have a GCD of the positive degree. That is the idea. And so we can prove this simple, that is f of x is divisible by the square of the polynomial, that is g of x whole square. some non-constant g of x, then f dash of x equal to 2g of x and g dash of x h of x. So that means plus g of x whole square, into h dash of x, that is uv formula apply பண்ணிருக்கோம். And g of x common ஆ வெளிய எடுத்துங்க, this is the result. So from this, what is the g of x divides both f of x and f dash of x. So GCD of f of x and f dash of x has a positive degree. So the same way, degree of that is the divisor is GCD of f of x, f dash of x positive degree. G of x is irreducible factor of d of x. So g of x divides both f of x and f dash of x. So f of x into g of x into h of x, and f dash of x into the defined like that. So g of x divides f dash of x. So therefore degree of g dash of x less than degree of g of x. G of x doesn't divide g dash of x, therefore g of x is irreducible and g dash of x is either 0 or lower degree. So g of x divides h of x. So g of x whole square should be divides f of x. So f of x divisible by the square of the polynomial. Okay, but proof புரியுதோ இல்லையோ, that the result is ஞாபகம் வச்சுக்கங்க. அது ப்ராக்டிஸ் பண்ண பார்க்க ஞாபகம் இருக்கும். Be the field and then you write the test, that is very useful. And be the field of integers, be the field of integer modulo p, modulo p is a prime, and f of x belongs to, that is means zp. Okay, that is the zp, and f of x belongs to f of x be irreducible polynomial over of degree n, irreducible polynomial of degree n. The f of x by this is a irreducible means obviously f of x by f of x is a field. What is the number of elements? The number of elements is the p power n. Number of elements is the p power n. Okay, so this is irreducible, that is the field of zp. இதை தான் யூஸ் பண்ணி முன்னாடி வந்து 121 சொன்னோம். That is the 121 சொன்னது காரணம், that is the idea. The degree 2ன்றதுனால 11 square is the 121. Okay, இதை யூஸ் இந்த ரிசல்ட் யூஸ் பண்ணி தான் சொன்னோம். So the result is very very important. டிஆர்பியை பொறுத்த மட்டும் ரிசல்ட்டாகவே கேட்பாங்க, ப்ராப்ளம் கேட்குறத விட. ஆனால் இது இந்த பாட்டை பொறுத்த மட்டும் ப்ராப்ளம் கேட்கறதுக்கு நிறைய வாய்ப்புகள் இருக்குது. இஸ் அ ஃப்ரூட். ஸோ இதுதான் பார்த்தோன்னு நினைக்கிறேன் ஆல்ரெடி. ஓகேவா, திஸ் இஸ் அ p equal to 2 here and f of x equal to something irreducible over z2, p equal to 2, and so this is the degree 2. So this is the field f of x divided by, this is a field with 2 square equal to 4 elements. What are the 4 elements? 0, 1, x, x plus 1. It's also very important. And the addition multiplication tables can be computed modulo x square plus x plus 1. So that is the idea. And now specialize our discussion to the polynomial with coefficients in rational numbers q. We will work the polynomial having integer coefficients. The central concern is the determining the such polynomial are irreducible over q. Okay, that is the definition of the primitive polynomial. So that means the polynomial of degree n or with integer coefficients is said to be primitive if the greatest common divisor of the coefficient should be equal to 1. Greatest common divisor of the coefficients, integer coefficient, should be equal to 1 ஆகுதுன்னா that is called the primitive polynomial. அப்படின்னா இது பார்த்தீங்கன்னா this is the primitive polynomial. 3, 6, 9 இது மூணுத்தினுடைய GCD வந்து is 3 is equal to 3, which is not equal to 1, so is not a primitive polynomial. It's not a primitive polynomial. இங்கே 3, 6, 5 இருக்குது, இதனுடைய GCD 1 வருது, so it is a primitive polynomial. இங்கே 1, 2, 3 வருது, so this is the GCD 1, so this is a primitive polynomial. So very simple, GCD of the coefficients of the polynomial is 1 or that is called the primitive polynomial. அதே மாதிரி product of the primitive polynomial is also primitive polynomial. Product of the primitive polynomial is also primitive polynomial. And the content of the polynomial, that is also, what do you mean the content of the polynomial? So the here also the coefficient is the integer coefficients. the greatest common divisor of the coefficients of the is the greatest common. The content means the greatest common divisor of GCD of the coefficient of the polynomial. இப்போ ஃபார் எக்ஸாம்பிள் இங்கே பார்த்தீங்கன்னா content of this polynomial நமக்கு வேணும்னா GCD of 6 9 12 GCD of 6 9 12 equal to 3, that is called the content of this polynomial GCD of 1 2 3 4 is equal to 1. So this is the primitive polynomial also, and then the content of this one is 1, content of this one is 1, இது content வந்து 3. okay, so இதெல்லாம் கேட்கலாம். so factorization into the content and primitive part. so D is the content of the P of X, D is the content of the polynomial P of X, that is the positive integer. Q of X is the primitive polynomial, Q of X is the primitive polynomial. The factorization is unique up to the sign of D, up to the sign of D. so take D equal to 0, so 6x square plus 9x plus 12, when you common multiple 3 வெளியே எடுத்துட்டீங்கன்னா 2x square plus 3x plus 4 அப்படின்னா இங்கே பார்த்தீங்கன்னா 3 D equal to 3, D equal to 3, and 2x square plus 3x plus 4 என்றது primitive polynomial. so this is the D equal to 3 is the content, that is the content. so content into primitive polynomial, we get that another polynomial. okay, and the significance of the primitive polynomial is irreducible over Z. Primitive polynomial is irreducible over Z if only if it's irreducible over Q or it's irreducible over Q. okay, irreducibility test such the essence criterion அப்படினு சொல்லுவாங்க, that is called the polynomial factorization algorithm for factoring the polynomial over Q. okay, but that is the primitiveness. and Gauss lemma பார்த்தீங்கன்னா that is the primitive polynomial f of x. so the primitive polynomial f of x can be factored as the product of two polynomials having rational coefficients, okay, and then it can be factored as the product of two polynomials having integer coefficients. okay, so the integer monic polynomial, this is also very important one. okay, the Gauss lemma, that means primitive polynomial can be factored as a product of two polynomials having rational coefficients, then it can be factored as a product of two polynomials having integer coefficients. okay, rational coefficient உள்ளத factor பண்ண முடிஞ்சதுன்னா integer coefficient உள்ளத factorize பண்ண முடியும், that is the for the primitive polynomial. and this is a Gauss lemma, and definition of the integer monic polynomial. a polynomial is said to be integer monic if all its coefficients are integers and its leading coefficient is 1. leading coefficient means highest power நோட coefficient வந்து 1. இதெல்லாம் integer monic polynomial, coefficient வந்து integer இருக்கு, highest power நோட coefficient 1. இது வந்து not a monic polynomial, இதுக்கு பேரு monic polynomial கிடையாது, not a monic polynomial because of இங்க coefficient வந்து 2 இருக்கிறதுனால not a monic polynomial. this is x square plus 1 by 2x plus 1 ஆன்னு கேட்டீங்கன்னா இதுவும் not a integer monic polynomial because of இந்த rational number வருது, rational number cross multiply பண்ணீங்கன்னா உங்களுக்கு ஆட்டோமேட்டிக்காக வந்து இங்கே 2x square இருக்கு. so the coefficient not an integer, so it is a not integer monic polynomial. and if an integer monic polynomial factors as the product of two non-constant with rational coefficients, then it factors as the product of two integer monic polynomial. so if an integer monic polynomial factors as the product of two non-constant polynomial with rational coefficients அப்படி இருந்தா then it factors as the product of two integer monic polynomial நாம எழுதலாம் அப்படின்றாங்க. that is next பார்த்தீங்கன்னா Eisenstein criterion, that means the polynomial எல்லாமே ரொம்ப இம்பார்ட்டன்ட், அதனால தான் அவங்க polynomial rings வச்சுருக்காங்க உங்கள் சிலபஸில். so f of x equal to a0 plus a1x a2x square plus and so on a in x power n be a polynomial with integer coefficients. suppose there exists a prime number p, that means p doesn't divide the highest power polynomial nth degree polynomial x power n உடைய coefficients. okay, but suppose there exists some prime number that is p. P doesn't divide an. P does not divide the leading coefficients. That means p divide ai for all I equal to 0, 1, 2 and so on n minus 1. P divides all other coefficients, and p square doesn't divide a naught. P square doesn't divide a naught. So p square doesn't divide the constant term. இந்த கண்டிஷன்லாம் சாட்டிஸ்ஃபை பண்ணுச்சுன்னா கண்ணை மூடிட்டு சொல்லிடலாம் தட் இஸ் த irreducible ஓவர் ரேஷ்னல் அப்படின்னு சொல்லலாம். irreducible ஓவர் ரேஷ்னல் நம்பர் அப்படின்னு சொல்லலாம். ஓகேவா? தட் இஸ் அ வெரி வெரி இம்பார்ட்டண்ட் ஐசன்ஸ்டீன் கிரைட்டீரியன்றது. ஸோ தட் இஸ் த irreducible டெஸ்ட் செக் பண்ணுறதுக்காக இந்த கிரைட்டீரியன் யூஸ் பண்ணுறோம். அதுவும் கேட்கலாம், விச் ஆஃப் த ஃபாலோவிங் ஃபார் த டெஸ்ட் ஆஃப் த irreducibilityன்றது. ஸோ ஐசன்ஸ்டீன் கிரைட்டீரியன்றது ரொம்ப இம்பார்ட்டன்ட். இப்போ எங்கள் எக்ஸ் பவர் n மைனஸ் பின்றது இஸ் irreducible. So for some prime p, okay, n greater than equal to 1, the polynomial x power n minus p is irreducible isomorphic criterion. So isomorphic criterion என்ன சொல்லுது? the highest pன்றது prime number, highest coefficient divide பண்ணக்கூடாது. highest coefficientறது இங்க 1, p doesn't divide 1, and p divides all other coefficients. Yes, obviously all other coefficients including and p ஸ்கொயர் ஆல் அதர் கோஎஃபிஷியன்ட் இங்கே இருக்கிறது ரெண்டு கோஎஃபிஷியன்ட்ஸ் தான். எனது 1 அண்டு p, 1 அண்டு p ரெண்டு கோஎஃபிஷியன்ட், ரெண்டுத்தையுமே வந்து pன்றது டிவைட் பண்ணும். சாரி 1ன்றது p மட்டும்தான் இங்கே அதர் கோஎஃபிஷியன்ட் வரும்போது. ஸோ pன்றது டிவைட் பண்ணும், அண்ட் கான்ஸ்டன்ட் நம்ம p ஸ்கொயர் டிவைட் பண்ணாது. ஆப்வியஸ்லி p ஸ்கொயர் டசன்ட் டிவைட் த p. ஸோ இந்த எல்லா கிரைட்டீரியாவும் சாட்டிஸ்ஃபை பண்ணுறதுனால திஸ் இஸ் கால்ட் தி irreducible. Okay, and cyclotomic polynomial, and what do you mean the cyclotomic polynomial means? X power p minus 1 plus x power p minus 2 plus and so on plus x plus 1, where p is a prime. Okay, this is a irreducible. Okay, is it irreducible? Can be shown to be the irreducible using the substitution and isomorphic criterion. ஸோ இப்போ ஃபார் எக்ஸாம்பிள் இதை எடுத்துட்டிங்கன்னா இங்கெல்லாம் பாருங்கள், திஸ் இஸ் த p minus 1, p minus 2 and so on something, 2x cube minus 6 square plus 9x minus 12. ஸோ இங்கே பார்த்தீங்கன்னா அந்த isomorphic criterion பார்த்தீங்கன்னா, ஸோ தட் இஸ் with p equal to 3. So p3 doesn't divide 2 and 3 divides other coefficients, minus 6 and 9 and 12, 3ன்றது டிவைட் பண்ணும், and 3 square, that is a 3 square equal to 9, doesn't divide the constant term. So the polynomial is reducible over q. Okay. And as the criterion is one of the few general tests of the irreducibility of the polynomial over q. It's particularly useful because it is easy to apply and work for the polynomials of any degree. It often used with the substitution x tends to x plus c, even when the original polynomial doesn't satisfy the condition. Okay, it often to be used with the substitution x tends to x plus c, x is equal to x plus c. எப்போனா even when the original polynomial doesn't satisfy the condition, satisfy பண்ணலனா we can apply like that. So the results form of the foundation for the studying the polynomial factorization over the rational coefficients are essential tool in the algebraic number theory. This is that. And the generalization of the Gauss lemma, that means D be the Euclidean ring and F is field of quotients. If a primitive polynomial f of x belongs to d of x and factors as a product of polynomial with the coefficients in f, field f, d into the Euclidean ring. If a primitive polynomial factors as the product of polynomial with the coefficient in the field f, then its factor as the product of polynomial, product of adunade factor as the product of polynomial with the coefficient in d, that is the Gauss lemma, generalization of the Gauss lemma. Dன்றது யூக்ளிடியன் ரிங் அண்ட் Fன்றது ஃபீல்டு. ஒரு ப்ரிமிட்டிவ் பாலினாமியலை நம்ம ஃபேக்டரைஸ் பண்ணுறோம், ப்ராடக்ட் ஆஃப் த பாலினாமியல் வித் கோஎஃபிஷியன்ட் வந்து இன் எஃப்ல இருக்கிற மாதிரி. அந்த ஃபேக்டர்ஸை திருப்பியும் ஃபேக்டரைஸ் பண்ணலாம். தென் இட் ஃபேக்டர்ஸ் ஆஸ் அ ப்ராடக்ட் ஆஃப் பாலினாமியல் with coefficient in D. That is the Gauss lemma. That is the Gauss lemma. Factors பண்ண the factors we can again factorize. It's a very simple idea. And irreducibility of x power n minus p already discussed பண்ணோம்னு நினைக்கிறேன் over the rational. That is satisfy the conditions. This is the factorization. Irreducibility of the cyclotic polynomial for the prime index. So the polynomial qp of x is the very and the cyclotic polynomial x power p minus 1, x power p minus 2 like this. P is a prime number, is irreducible over the rational. This is irreducible over rational. So that so the qp of x into we can express xp minus 1 divided by x minus 1. Already we know that. So this is factorize பண்ண முடியுது. X minus 1, x power p minus 1 something, and y equal to substitute x, y equal to x equal to y plus 1. So y plus 1 whole power p, the substitute பண்ண சொன்னாங்களே, that is y plus 1 whole power p minus 1 divided by y. the substitute பண்ண பிறகு எக்ஸ்பேண்ட் பண்ணிட்டு either 1 1 cancel ஆகிடும். ஸோ மிச்சம் இருக்கிறத y ஆல் டிவைட் பண்ணிங்கன்னா once again we get the same polynomial, the structure. So applying the Eisen's condition for the qp pi p y plus 1 and the x equal to c plus 1 போட்டதுக்கு Eisen's condition apply பண்ணீங்கன்னா, so with prime p, so the leading coefficient 1, அதனால p doesn't divide that one, and all other coefficients divided by p, p c k என்றதுனால, that is p னுடைய multiple என்றதுனால, so p c k என்றது we can express like this, p factorial divided by k factorial p minus k factorial, மேலே p into p minus 1 factorial எடுக்கலாம். அதனால p ஆல் டிவைட் ஆகும் all other polynomial. Constant term is p, அதனால p தான் divides p, p square cannot divides p, p square என்றது cannot divides p. so எல்லா conditions satisfy பண்ணுது. so pi p y plus 1 is reducible over q. so pi p x is reducible, but pi p x equal to f of x into g of x, அதான் நம்ம என்ன பண்ணணும், y plus 1 something எழுதணும். but pi p y plus 1 f of y plus 1 g of y plus 1 like that is would also be reducible if pi p y plus 1 is irreducible. Pi p y plus 1, if this is reducible, then pi p y plus 1 is irreducible, pi p x must be irreducible as well. Okay, so contradiction arise ஆகுதுங்க. so அதனால this is இது irreducible நமக்கு தெரியும். the contradiction எது arise ஆகுதுன்னா, because of pi p x is irreducible, so therefore pi p x should be irreducible. that is the idea. okay, pi p x is irreducible as well, and the coefficients ap minus 1, numerator is a p factorial, that is and another one is rational root theorem. I thought rational root theorem I thought 11th standard book liye irukku nenikiren. that is f of x equal to like this, be a polynomial with integer coefficients. the m by n is a rational root in the lowest term, then m divides c naught, that is constant term, and n divides cr, that is a coefficient of x power r, coefficient of x power r. so 11th standard book refer பண்ணுங்க, 11th or 12th, I thought 12th standard book, 12th standard book refer பண்ணுங்க. then we get it the idea about the rational root theorem. நிறைய example கொடுத்திருப்பாங்க நினைக்கிறேன், some examples. okay, so here so x cube minus 2 as a possible roots அப்படின்னு பார்த்தீங்கன்னா, that is plus or minus 1 plus or minus 2. there because of please try to join or any other problem. So the coefficient, the possible roots are plus or minus 1, that is 2 nude possible root, that is plus or minus 1 plus or minus 2. Test apply பண்ணீங்கன்னா that is இங்க coefficient பார்த்தீங்கன்னா that is the plus or minus 1, highest power node coefficient, that is called the rational root theorem. F of x polynomial with integer coefficient, that is m divides c naught m, and the rational number is a rational root in the lowest terms, that is the rational root இருக்கணும்னா what are the condition na the numerator வந்து rational rootல numerator வந்து should divide c naught constant term and denominator divides cr. இங்க பாத்தீங்கன்னா so 2 nuடைய factors of 2 is plus or minus 1 plus or minus 2, the correct factors of 2, and factors of 1 பாத்தீங்கன்னா factors of 1 அதான் highest CRன்றது r3 degree polynomial, அதனுடைய x power r னுடைய coefficient is CR, denominator divides CR, that is இங்க x cube னுடைய coefficient 1, so 1 னுடைய factor பாத்தீங்கன்னா plus or minus 1. actually இது ரெண்டுத்தையும் divide பண்ணணும், that is the p by q form இல்ல m by n form. அப்படின்னா plus or minus 1 divided by plus or minus 1 இல்ல plus or minus 2 divided by plus or minus 1. அப்படின்னா ஆக்சுவலாக பார்த்தீங்கன்னா உங்களுக்கு கிடைக்கிறது plus or minus 1 plus or minus 2. this is என்னது m by n form. இந்த 4 ரூட்டில் 4 ரேஷனல் ரூட் இதுக்கு பாசிபிலிட்டி இருக்குது. ஓகேவா, ரேஷனல் ரூட் பாசிபிள் ரேஷனல் ரூட் பார்த்தீங்கன்னா plus or minus 1 plus or minus 2. ஸோ அதெல்லாம் செக் பண்ணுறோம். f of 1 அந்த பாலினாமியில் போட்டு which is the following the root அப்படின்னு f of 1, f of minus 1, f of 2. so no rational root for this one. so the no rational root is exist confirming the irreducibility over q. so அதனால இது rational root இல்லாதனால that is another irreducibility is over q அப்படின்னு சொல்லலாம். so இது one of the test. okay, rational root theorem. so இதே மாதிரி இங்க பாத்தீங்கன்னா 6 னுடைய ஃபேக்டர் பாத்தீங்கன்னா so the factor of 6 அதான் m, factor of 6 ன்றது தான் m. so the factor of 6 ன்றது plus or minus 1 plus or minus 2 plus or minus 3, அப்புறம் plus or minus 4 வராது, 5 வராது, plus or minus 6. okay, and factors of 2 n equal to factor of 2 னுடைய ஃபேக்டர் பார்த்தீங்கன்னா plus or minus 1 plus or minus 2. okay, ஸோ ரெண்டுத்தையும் டிவைட் பண்ணிங்கன்னா plus or minus 1 by plus or minus 1 plus or minus 1, அப்புறம் plus or minus 2. இந்த plus or minus 1ஆல் டிவைட் பண்ணும்போது அதே அப்படியே வந்துடும். அப்புறம் வந்து இந்த plus or minus 2ஆல் எல்லாத்தையும் டிவைட் பண்ணுவோம், 1 by 2 வரும், அண்ட் 2 by 2 1, 2 by 2 1ன்றதுனால ஆல்ரெடி வந்துடுச்சு. 3 by 2 வரும், 6 by 2ன்றது 3, அதனால் 3 by ஆல்ரெடி வந்துடுச்சு. ஸோ இவ்வளோ பாசிபிலிட்டிஸ் இருக்குது. ஓகே, ரேஷனல் ரூட். ஸோ ஐ தாட் 3 by 2ன்றது சாட்டிஸ்ஃபை பண்ணுது. ஓகே, 3 by 2ன்றது ரூட்டாக இருக்குது. ஸோ திஸ் இஸ் த ரூட்டுன்றதுனால இதை வந்து irreducible நான் சொல்ல முடியாது, 3 by 2 ரேஷனல் ரூட் இருக்கிறதுனால. ஸோ தட் இஸ் த ஐடியா ஆஃப் த ரேஷனல் ரூட் தியரம். ஓகே, irreducibility நீங்கள் எப்படி செக் பண்ணாமோ அப்படி செக் பண்ணலாம் கொடுத்துருக்க பாலினாமியலுக்கு. ஸோ இங்கே r be the r of x. r of x na the polynomial ring in x over r, the set of formal expression. the coefficients is the real number. The coefficient is the real number. that is the ring of polynomials in n variables. ring of polynomials in n variables x1 x2 xn over r, that is r of x1 x2 xn is defined r1 of x na r of x1, r2 of x na r1 of x2, that is r of x1 x2. like this rn என்றது r of x1 x2 xn. okay, so இதனுடைய elements of the form like this and operation வந்து like this define பண்ணுவாங்க. and integral domain property, that means integral domain property or is an integral domain இருந்தா இதெல்லாம் ரொம்ப ஈஸியான ஞாபகம் வச்சுக்கூடிய ரிசல்ட்டு. உங்களை டிஆர்பி பொறுத்தவரை டைரெக்டாக கேட்கக்கூடிய வாய்ப்புகள் நிறைய இருக்கிறது. ஆர் இஸ் அன் இன்டெக்ரல் டொமைனா ஆர் ஆஃப் எக்ஸ் இஸ் ஆல்சோ இன்டெக்ரல் டொமைன். ஆர் இஸ் அன் இன்டெக்ரல் டொமைனா தட் இஸ் ஆர் ஆஃப் x1 x2 xn is also integral domain. And a field of rational functions, so f is the field, f of x1 x2 xn is an integral domain. So construct is the field of fraction, that is the field of rational functions in x1 x2 xn over f denoted by f of x1 x2 xn. Elements of f of x1 x2 xn are of the form f of x1 x2 xn divided by g of x1 x2 xn, with the g of x1 x2 xn is not equal to 0. The field plays a fundamental role in algebraic geometry and Gauss theory, that is okay. The divisibility theory in integral domains, in integral domain R with unit element, the element u in R is such that there exists v belongs to R, u equal to 1. Already நாம் பார்த்ததான் நேற்று. அசோசியேட்னா that is ரெண்டு எலமெண்ட் belongs to R or அசோசியேட்னா ஒரு எலமெண்ட்டை u into b ன்னு எடுக்கலாம். uன்றது யூனிட், யூனிட்ன்றது there exists another element, the product is equal to 1. அதே மாதிரி irreducible element ன்னு ஒன்று இருக்குது, that is the a non-unit element a belongs to R is irreducible அப்படி நான் சொல்லணும்னா a equal to bc ன்னு எழுதணும். bcன்றது belongs to R, இதில் either b or c வந்து யூனிட்டாக இருக்கணும். யூனிட்டாக இருந்தால் that is called the irreducible element இல்லை prime element அப்படின்னு சொல்லுவோம். So and R equal to f is a field, already we know that f of x is a Euclidean domain. So Euclidean domain that is obviously principal ideal domain, unique factorization domain, that is implies Napier purpose. So units in f of x, non-zero constant polynomial, non-zero constant polynomial, irreducible polynomial, these are those that cannot be factored non-trivially, that is r equal to z into the integer, z of x into the integral domain but not a principal ideal domain, and a unit of z of x into the plus or minus 1. Z of x is a unique factorization domain by the Gauss lemma. R equal to f of x1 x2 xn minus 1, this is an integral domain, not a principal ideal domain, and the ideal is not principal, and but it not a unique factorization domain. It is a unique factorization domain, and unique factorization domain definition means the integral domain R with unit element. Integral domain R with unit element is a unique factorization domain if any non-zero element in R, any non-zero element in R is either a unit or can be written as a product of finite number of irreducible elements. Finite number of irreducible elements of R. The decomposition is unique up to the order and associates of the irreducible element. That is we call the definition. So Z is the unique factorization domain. F of x into the field over the polynomial over the field is a unique factorization domain. Any Euclid domain is a unique factorization domain. Non-example f of x1 x2 is not a principal ideal domain. It's not a Euclid domain, but as it is a unique factorization domain. So R is a unique factorization domain. A comma b belongs to R. Then a comma b have the greatest common divisor, and in R a be relatively prime, and a divides bc, then a divides c. Suppose a is the irreducible, then a divides bc, then a divides b or a divides c. So definitely இதெல்லாம் கண்டிப்பாக படிச்சு தான் ஆகணும். It's a very important role, and the content of the polynomial already discussed, GCD of the something, and the Gauss lemma for the unique factorization domain. R is a unique factorization domain, then the product of two primitive polynomials in R of x is again a primitive. And content is multiplicative. The content of fg equal to content of f, content of g in eduthalam, and a ratio between the R of x and q f of x. So R be a unique factorization domain of fraction f, then R of x should be contained in f of x. So that is f of x equal to any polynomial f of x equal to f naught of x divided by a. Okay. Irreducibility in R of x versus f of x. F of x belongs to R of x be a primitive, so f of x is irreducible in R of x. Then it is irreducible in f of x. And irreducible f of x is irreducible in f of x. Then it is irreducible in R of x. That is the conjunction of so the example pathina, this is the 2x plus 4 is as content 2, as a content 2. Primitive part is x plus 2, the primitive part is x plus 2. So that means primitive part into content is equal to the given polynomial. So the polynomial is a primitive, and Gauss lemma tells that we want to factor the polynomial in z of x. We can first look at the factors in q of x. So unique factorization, R is the unique factorization domain. P of x is a primitive polynomial in R of x. Then it can be factored in a unique way as the product of irreducible element in R of x. So R is the unique factorization domain, implies R of x is the unique factorization domain. Is also unique factorization domain. So this is the Z is a unique factorization domain, Z of x is a unique factorization domain, and f is a unique factorization domain, and the polynomial f of x1, x2, xn is a unique factorization domain. Z of root of minus 5x is a unique factorization domain. So this is not a unique factorization domain because of 6 equal to 2 into 3. That is 2 is we can express 1 plus root of minus 5, 1 minus root of minus 5. So we cannot apply the theorem to conclude that z of root of minus 5 into x is a unique factorization domain. So this is can be factorized. That is therefore that is not a unique factorization domain. Not a unique factorization domain. Q of x comma y is a unique factorization domain. R of x y z is a unique factorization domain. This is not a unique factorization domain. Okay, I will stop here. So tomorrow see you.